in this lecture, we are going to talk about test and measurement of a buck converter using digital storage oscilloscope. I am Dr. Shantanu Kapat and with me Nitin Nigam from Keysight Technology. And in this lecture, we are going to talk about working hardware prototype of a digitally controlled buck converter and debugging and validation of a buck converter using digital storage oscilloscope. And here we are going to consider our test kit, which is a digitally controlled buck converter prototype, and we'll be talking about current mode control with inner current loop in a buck converter. So with this, I want to hand over to Nitin from Keysight Technology.
Hello everyone, my name is Nitin Nigam. I am working as a solution engineer for Keysight Technologies. Keysight is a global leader in test and measurement instruments. Keysight manufactures instruments such as oscilloscope, power supplies, also spectrum analyzers, optical sources, optical laser, and etc. Today in this lecture, we will be demonstrating and measuring the validation of a buck converter using a Keysight Infinium oscilloscope MXR series. Today we have a setup. We have a buck converter which is being powered on by a triple output DC power supply from Keysight. We have a channel 1 which is connected on a voltage. We have a channel 2 current probe connected on the channel 2 of the oscilloscope. Before doing these measurements, there are a couple of important tips that needs to be done in the oscilloscope settings. First of all, we need to understand the type of a coupling that we are using. In the oscilloscope menu, we have a setting which is known as the AC coupling or a DC coupling, which is a quite important factor when we are doing such type of a measurements. DC coupling, as you all understand, it shows you DC and AC component both into the signals, but if you are just measuring the AC ripple, it's always better to use an AC coupling so you can switch off the DC component on the specific signal. It's a very important setting that needs to be done in the oscilloscope. Second important thing that needs to be done in the oscilloscope before doing these measurements is related to the bandwidth limit. When we do these measurements, as we understand, the signals might be in terms of hertz, might be in terms of kilohertz. So it's very important to do the bandwidth limit on a specific channels on which we are trying to do the measurement. When we talk in terms of the bandwidth limit, it specifies the type of hardware bandwidth limit that we impose on that particular channel. We have a dedicated setting where we can choose in the type of bandwidth limit accordingly to the measurement. We can choose 20 megahertz, we can choose 200 megahertz, and we can also set up a custom bandwidth limit. This helps you to capture your signal in a much high resolution mode and you can do the measurement more precisely. Going back to the measurements, Keysight offers a very powerful tool which is known as a power analysis tool. Power analysis tool gives you a complete platform on the measurement that needs to be performed on a specific voltage and current signals. When we go in the menu of the power analysis tool, we could see there are a couple of measurements. There are input measurement. When we talk in terms of the converter, from the input side, there are input power that needs to be measured. It might be a apparent power, it might be a real power, it might be a true power, power factor, phase angle, other measurement that's on the input side. From the output side, if we talk in terms of the ripple measurement, if from the efficiency, or from the switching side, if you wanted to do the switching on characteristics of the MOSFET, maybe it's turn on losses, conduction losses, turn off losses, all those measurements these particular measurements are incorporated in a single tool of the power analysis of the Infinium software. Along with these, we are giving the stability performance measurements also. We have a dedicated tool inside this particular package which is known as frequency response measurement, this particular measurement tool can be used to measure the Bode plot analysis. It can be used for measuring the PSRR on that particular signal. Let's just take an example of a specific measurement. If you go into input measurement, we have this power quality. We just need to select the sources on which the channel it is being connected. If you are connecting on channel 1, we choose channel 1 in the menu. If you have connected a channel 2, we choose channel 2 as a current or a voltage specifically, and then we do our settings accordingly. Simply switching it on will give you the measurement on the bottom side of the screen. We could see there are a couple of measurements which are being displayed on this specific tool, and then you can take the measurements accordingly. We have a dedicated setup wizard. Let's say if you are not familiar with the tool itself, a setup wizard will give you a step-by-step guide where you can set up your signals, you can set up your measurements, and you can choose the type of measurement that you wanted to take. This step-by-step guide gives you a dedicated platform on which you wanted to take the measurement. It tells you what measurements you require, it tells you what signals needs to be added, it tells you the connection diagram specifically which is required for that particular measurement, it tells you the settings, and it does the measurement by itself. So this particular tool is very useful characterizing of AC-DC, DC-DC, DC-AC power supplies. This is a dedicated tool which can be installed in offline. Going forward, we'll talk about that. This can be installed into the offline soft PCs. This can be installed in the oscilloscopes, and you can use it anywhere, any time that you require. A very dedicated tool or power analysis on Keysight oscilloscope. So from the DUT, we have connected an inductor current signal on the oscilloscope. On channel number 2, we have configured the specific settings which are required. When we go into channel number 2, we need to choose the type of the probes, and we select the scaling on the as per the scaling which is of the probe. Right? What we have chosen here in this case is a 10:1 ampere unit probe on this instrument. The measurement, we have configured the specific number of cycles that needs to be chosen into the oscilloscope for the measurement. There are typical measurements that we have done on this particular signal. Average values, the maximum value, the minimum value, the frequency and the amplitude of this particular signal. All of these measurements comes under a measure tab where we can choose the specific measurement related to that particular signal on the source that we would want to have. Thank you.